We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Hello, I'm John Vors at the CNN Center in Atlanta, and welcome to our viewers in the United States and around the world. At this hour, an incredible 570 million kilometer journey is coming to an end. NASA's rover Curiosity is on final approach to Mars, and soon it'll begin an extraordinary and complicated landing. Something like this has never before been attempted, and there is zero room for error. About 17 minutes from now, if all goes as planned, the rover will touch down on the Martian surface. But it takes 14 minutes for a signal to travel from Mars to Earth. So best case scenario, confirmation will come in about 31 minutes. And we expect the rover's first pictures from Mars at around 2 a.m. Eastern Time. That's 6 a.m. GMT at the earliest. Our Mars team is in place, ready to cover this every step of the way. Joining us from the U.S. Jet Propulsion Laboratory near Pasadena, California, is CNN's John Zarrella. CNN's Phil Black is in Moscow, where Russian space officials are closely following today's development. And Space.com science correspondent David Brody joins us from Edgewater, New Jersey. But first, we will go to John Zarrella live at the JPL laboratory there in Pasadena. And John, we're about to enter that period that officials are calling 7 minutes of terror, when they will not know if Curiosity is alive or dead.
That's exactly right, John. This is it. They've all been using the Olympic term that they have to stick this landing. And as you pointed out, that this maneuver to entering the atmosphere of Mars, traveling at 13,200 miles an hour. In less than 10 minutes from now, they'll be hitting, Curiosity will be hitting the upper part of the atmosphere, traveling at that speed. From that point on, it will maneuver its way down through the atmosphere. Then a parachute will deploy, and following the parachute deployment, it'll be slowed even further. And then another series of events has to unfold, where rockets have to fire, and the heat shield comes off, and the back shell comes off, and ultimately, Curiosity will be tethered down, literally a sky crane, down to the surface of the red planet, and then that next phase of the operation is to jettison that part of the spacecraft that lowered Curiosity down, and then and only then will it be safely on the ground. But if any one of those things goes wrong, the mission is lost. But if Curiosity gets down safely, it will be a 2-year adventure to look for the building blocks of life. The Grand Canyon, each layer of rock represents a period of history. It is a perfect place to see how Earth evolved over millions of years. On Mars, if you're looking for evidence of life, you go to a very similar place called the Gale Crater. Here, the layered rock provides a history of Mars back to its first billion years.
That period of Mars history is a mystery to us, but it's also the most exciting history for us, because that's when it was most Earth-like.
And that's when life is most likely to have developed. So Gale is where NASA's Curiosity rover is going, between a mountain and the crater wall.
And we're landing right between those two in kind of the only patch of flat ground.
You could call Curiosity the Sherlock Holmes of rovers, with a capability to do science that's more than just elementary.
This mission really asks one of the most fundamental questions you can ask, is there life on any other planet besides Earth?
Curiosity does not have the capability to detect life itself, unless life should stand up and wave at the rover's camera. But the 2,000-pound rover can detect what none of its predecessors could. Its laser scans for tantalizing targets. Its hammer drill breaks down rock and deposits tiny samples in Curiosity's onboard chemistry lab. The lab can sniff out organic materials like carbon, a building block of life.
One of the key goals is to look for the key ingredients that life requires. Water, of course, is one of the most one of the things we always look for on Mars.
Scientists believe if water ever flowed on Mars, it might have been inside Gale Crater. The vast majority of Curiosity's tasks will be orchestrated by scientists on Earth, but when you're 150 million miles away, there are some things Curiosity might have to do on its own.
The rover will be able to make decisions whether it can drive over an obstacle or if it needs to drive around an obstacle.
The rover's mission is expected to last about 2 years. At the end of it, scientists hope to finally understand whether Mars could ever have sustained life, or maybe even still does.
Hey, Joy, let me run that for you.
Now, just a few minutes ago in Mission Control here at Jet Propulsion Laboratory, the team handed out peanuts, which is an old tradition that dates back to the 1960s. Missions had failed, and there were many attempts before they actually passed out peanuts, and on the mission they passed out peanuts. They had a successful mission, and so now, ever since, they've been handing out peanuts on these attempts, and they've been doing quite well, John, and hopefully it will be good luck for them again. I can tell you, this place is quiet now. Everybody's in auditoriums watching. The science team is all gathered, the mission control team, but there are 400 credentialed media here. There are hundreds of dignitaries that are here. All kinds of folks have come here for tonight's event. And I've been here for several other Mars landings over the years, and this is by far the most excited I have seen this place in many, many, many years. John?
I can imagine you could cut the tension there with a meat axe right now. But
Yeah.
John, we've been working on this timetable. 17 minutes from now, we expect a touchdown. 31 minutes from now, at the earliest, we are expecting some kind of confirmation. But the time scale here is much broader than that. We're talking maybe 2 hours, maybe 8 hours before we hear anything from Curiosity.
Well, you know what? I'm going to bring in Joy Crisp. She's the deputy project scientist. And Joy, thanks for joining us. The question was, you know, it may be a while, even after it gets on the ground, or will it, before we'll hear from Curiosity? Is it going to come really quickly, or could this drag out?
It could drag out, unfortunately. But if everything goes as expected, then we'll hear right away. So right at about 10:31 Pacific time, we should hear.
And one of the reasons why is Earth is setting.
Yeah.
So you can't hear directly from Curiosity, correct? So signals are going to be relayed back through other orbiters.
Through Odyssey, yes.
And that's another orbiting spacecraft through Odyssey.
That's correct.
And if they don't hear from it on that pass, then you got to wait till Odyssey comes back around.
That's correct.
So how long is that going to be? Probably an hour and a half, 2 hours, right?
It's a couple hours, yeah.
So we really could be...
You might have to wait. I hope not.
I mean, I would assume everybody hopes that you hear right away. I mean,
Right.
then all the anxiety's over.
That's true.
What about you? What are you feeling right now? I mean, how long have you been on this project?
For 6 years.
6 years.
Yes. So it's been a real crescendo of emotion today, and been working hard to get everything ready, even things at home like filling up the car with gas and going to get groceries and just getting everything set so that I don't have to do those things when, after it lands.
You know, right about now, we're looking at probably about just a few more minutes before it reaches the top of the atmosphere.
Right.
Correct?
Yeah.
And then
Then we got the 7 minutes,
of
right?
terror. And it all begins.
Yeah.
John?
Okay, and we are keeping a very close eye on the clock because it is 17 minutes past the hour when we are hoping that we will get some kind of indication that Curiosity has actually successfully landed on the surface of Mars. Let's talk a little bit more about this actual mission for Curiosity once it does touch down, assuming that it does go according to plan. Dave Brody is the science correspondent for space.com. He joins me now via Skype from Edgewater in New Jersey. Dave, it is good for you to be with us. We appreciate it very much. In very broad terms, what is the mission for Curiosity?
Well, we're attempting to tell more of this water story on Mars. Mars looks like a place where a lot of water flowed for a very long time, a long time ago. And we want to know why it isn't there anymore. And if it was there long enough, did life form on Mars? Curiosity is not specifically going to be able to tell you whether or not life formed, but it will look for the telltale signs of former life in the form of organic compounds, complex organic compounds. Organics are, something is organic if it contains carbon and burns. That doesn't necessarily mean life. But as you get more and more complex organic molecules, well, that is a pretty good indicator of life. So Curiosity will be looking for that. Why do we want to know if there was life on Mars? First of all, it's just a burning question. But more importantly, we'd like to know why it is that the two planets around us, Venus on one side and Mars on the other, don't seem to be doing as well as Earth does, yet all three are in what's called the habitable zone, the Goldilocks zone, not too hot, not too cold, for water to flow and water to cycle, and perhaps life to form. Other thing that we need to know about life, if it is someday discovered on Mars, is does it have the same DNA that earthly life does? If it does, that's profound, because that means that it could be that life arose on Mars, perhaps, and came to Earth, or arose on Earth and came to Mars. Because of the dynamics of the early solar system, it's easier to believe that it started there and came here rather than the other way around. Or did life come from somewhere else and seed both planets? That's if it has the same DNA that we do. If it doesn't have the same DNA, but it was life, or is perhaps even life living now on Mars, that's even more profound, because that means that two little planets right next to each other independently formed life. And if that's true, then life, by logical extension, is probably ubiquitous throughout the universe. Lots and lots of life everywhere. So big questions, some of which we may get the beginnings of answers to from Curiosity and from its precursor missions, the Mars exploration rovers, Spirit and Opportunity. Opportunity is still functioning on Mars. Those guys told us an awful lot about this water story. So the water story continues.
Okay. Hey, Dave, we've got a big night ahead of us. We'd like you to hang with us for the rest of the hour, maybe a little bit beyond that, as we keep a close eye on this mission to Mars. So please stand by. Get a little bit more information about Curiosity and how it's following in the footsteps of other successful missions to Mars. Some of those other past successes include the Mariner series back in the 1960s, the first of many flyby missions to snap scores of pictures of the red planet. The first successful landing on Mars was by Viking 1 back in 1975. Dave mentioned that. Viking 2 sent back 16,000 images, as well as a lot of data. And as technology improved, NASA sent spacecraft to orbit Mars for longer studies, like the Mars Global Surveyor in 1996 and the Mars Reconnaissance Orbiter in 2005, which transmitted back to Earth more than 24 terabits of data, more than all the other Mars missions combined. A new generation of Mars rovers, Spirit and Opportunity, landed in 2004. And they've taken more than 100,000 high-resolution images, countless details about the minerals on Mars, and Opportunity is still roving the Martian surface today. Now, we will take a short break here, and it is 17 minutes past the hour, so let's go back to JPL, just outside Pasadena in California. John Zarella is standing by to find out if everything has gone according to plan. Curiosity should be touching down on the surface of Mars. John, one scientist described this as a Super Bowl. They're on the 1 yard line. They've got one play left. How's it looking?
Yeah, that's exactly right. And, the reset for the viewers. This is the most complicated landing attempt ever by NASA with a spacecraft on Mars. And they had to do it because Curiosity is so big. You can see behind me, it's almost the size of a small car, about 2,000 pounds. On past missions, they were able to encase their rovers in airbags. They'd bounce on the surface of Mars, then come to a standstill. The airbags would deflate, and then you'd have these great little, these great little rovers that could just come right off the landers and take off. Well, this thing is way too big for that. They had to come up with this incredible set of maneuvers and pyrotechnics to get Curiosity on the ground. And Joy Crisp is with me again, Deputy Project Scientist. And Joy, good news, right? They were getting what they called heartbeats. What does that mean? Tell us.
Well, we're getting tones from the spacecraft as it's coming down. Not super complicated data, but just signals letting the team know how it's doing as it goes through the steps of EDL, entry, descent, and landing.
So far, what we're hearing is that means that it is alive and well on its descent to the surface.
That's right. So it's separated from the cruise stage, and it's headed down in through the atmosphere of Mars.
Now, because of that time delay, would it be on the ground by now and we just don't know it?
Yes, it would.
It would.
It's kind of amazing.
It is. And so right now, as far as you're concerned, I mean, this is the hurry up and wait.
Right. It's happened, but it really hasn't happened in our minds yet. So we have to wait and see how it proceeds.
We have some animation that the NASA team here put together yesterday that shows how the communications are going to be taking place, because you have actually 2 orbiting satellites up there.
Right.
You've got the Odyssey, right? And then you've got what, the reconnaissance orbiter?
Correct.
And those 2 are how we'll be communicating back to Earth.
That's correct. And the data that we're getting now from EDL, entry, descent, landing, is coming through Odyssey, what we call the bent pipe. It's coming straight to us rather than being stored on board the orbiter and recorded and sent down later. That's how we'll get our data.
So this is as real-time data as you can get.
Yes. So this is what we were really hoping for, was that Odyssey would rotate and then be able to do this bent pipe for us and let us know as you know, right now, let us know what was happening. And without that, it wouldn't be possible.
We wouldn't know, right? John, so we just got a few more minutes here to wait, probably another 10, 11 minutes. Hopefully, we will know definitively, hopefully, that Curiosity is on the ground on Mars, 150 plus million miles away.
And John, once it's there, it will start getting to work pretty much straight away, collecting samples, yes?
No, it will not. They're not. What they will do, we'll get some images pretty quickly. We'll get thumbnail images, they call them. The first one will be an image of one of the wheels.
Well, one caveat.
Caveat.
It depends on when exactly we land, because we don't know the characteristics of the atmosphere. So we don't know when exactly Odyssey will be, communicating. So we may or may not get those initial images. So we might get a few thumbnails, but we're not sure.
We're not sure.
Yeah.
So we might not even get those pictures. But to answer your question, it's going to take about 3 weeks of checkout of the vehicle before they actually get down to the science. But once they do, it's a 2-year mission, so a lot of time to find to find all those signatures, hopefully, of life that once existed or perhaps still does on Mars.
And again, John and Joy, we appreciate you both being with us, and please stay with us for a little longer. You're watching World Report. We're keeping a very close eye on the situation with Curiosity, which we now understand should be on the surface of Mars, and we're awaiting official confirmation of that in the coming moment. We'll have more after a short break. Jet Propulsion Laboratory just outside Los Angeles in California, as the Curiosity rover is now, we believe, on the surface of Mars, still waiting for confirmation of that. We are watching and waiting here at CNN. We have John Zarella at the JPL laboratories there in Pasadena. We also have Phil Black, who is in Moscow, because the Russians are actually playing a significant role in this mission, and they have a lot of experience at sending probes to Mars, and a lot of it successful. But let's just go back to John at JPL. John, any more heartbeats, any more signs of life, if you like?
Yeah, you know, what you're going to do with this vehicle when they talk about looking for the, you know, the signs of life, they're getting these little bleeps right now from Curiosity that it's alive. But now as we're watching the images here, you know, it's still very quiet. They're all in great anticipation, waiting, as everybody is, for that signal to be relayed back to Earth that says, hey, I'm here and I'm alive and I'm well on the surface. And it's still going to be a few minutes, John, before we have that first confirmation. And as we were talking earlier, it even could be quite a bit longer than that if the things don't align just right.
I make it just about 6 minutes, hopefully, before we get some indication from Curiosity. John, thank you for that. Let's go to Phil Black, who is standing by at CNN in Moscow. And Phil, the Russians are actually contributing to this mission, and they have a lot of experience, and a lot of it good, when it comes to sending probes to Mars.
Yeah, John, in this particular mission, their involvement is very specific, and it relates to the science and exploration phase of the mission. The rover is carrying an instrument that has been supplied by the Russian Space Agency that will be used to detect and measure hydrogen beneath the surface. The possible presence of hydrogen would indicate the possibility that there could be water or ice beneath the surface. So that's their involvement there. But you're right in saying that Russia's experience in getting to Mars, or trying to get to Mars, is considerable. They know just how difficult it is to stage a mission like this, because they've been trying to do it, well, for some decades now. It was a long-standing priority of the Soviet space mission to explore the Red Planet. They had some successes, they had more failures. And post the Soviet Union, there have been two significant attempts to get there as well. Both were unsuccessful. The most recent was just in November last year. The Phobos Grunt spacecraft was designed to travel to the Phobos moon of Mars, land, collect a sample from the ground there, and then return to Earth. It was hugely ambitious. It had been years in the planning, but the failure was really quite embarrassing, because it was not long after takeoff that the spacecraft failed. It never escaped the Earth's lower orbit, and it eventually, some months later, fell back to Earth and broke up on re-entry. But Russia has not given up on getting back to Mars. It is planning future missions already, one of which with the European Space Agency in the coming years, John.
Phil, we want to go to JPL because it looks like there is some developments there. We can see some very excited NASA engineers at Mission Control. John Zarella is at JPL, essentially Mission Control there, just outside Pasadena in California. John, what are they saying?
Well, you know, this is because we've got this 14-minute delay in transmissions coming back to Earth. They're just now getting the transmissions of things that already happened 14 minutes ago. So I'm going to bring Chris back in. And Joy, what are we hearing? I just heard them say they're right on line with the target, right?
And the part that's going to make this evening very pleasant is that we have data coming from Odyssey. So
and that's
that
the orbiting spacecraft
working. So we'll get to hear all the steps of the entry, descent, and landing.
So the link between Curiosity and Odyssey is up and running
and coming back
to us on Earth. So everything that is happening, that happened already, but that we're just hearing now, is things you might not have known if you didn't have this link.
And we don't have to wait for later hearing
so
it from
we
a
will
recording.
know now.
Yeah.
We will know in just a matter of a couple of minutes now, John, whether all of the pyrotechnics, all of this incredible landing maneuver that they are attempting for the first time is a success. Just a couple minutes away now, I would assume.
And
is
then
that about right, Joy?
Say it again.
A couple minutes away.
Yes.
John?
The thing which I found interesting about this mission compared to all those other missions is that we're talking about a rover here which will be nuclear powered, and if it is successful, could continue to explore the surface of Mars, not just for the 2 years, which is the expected life of this mission, but for much longer.
Yeah.
Parachute.
Parachute?
Deploy.
I just want to interrupt you there. That was parachute is deployed. So now they're going to be slowing down to about 200 miles an hour on that parachute.
Yep.
And then comes the big event, the sky crane after that. But what you were saying was, yes, they have what's called an RTG that's powering this vehicle. That's a radioisotope thermoelectric generator, nuclear power. So while the power will last for up to 50 years or more, you know, a lot of the mechanical stuff probably won't last that long, John, but yeah, at least 2 years, and could last well beyond 2 years, right?
Yeah.
Yeah.
So
what is this? Wait a minute, John.
Sure.
Acquired the ground with the radar. They've acquired the ground with the radar, which means they're on those next phases, which means Curiosity's radar is now bouncing back off of the Martian surface to give it the height, the elevations, right? So they're coming down now. We're very close to a landing on the surface of Mars. John?
So essentially, this probe, this rover, has traveled at 13,000 miles per hour for virtually zero, and it is slowed in 7 minutes.
They expect to lose the communication directly to Earth
correct.
at about this time, late on the parachute.
It was late on the parachute?
That's when it should have occurred, so it's normal.
It's normal. We may lose the communication, they've lost a little bit of the communication link, correct?
I think the direct link.
The direct link. So now we may have to wait a little bit.
No, we're just still on Odyssey.
We're still on Odyssey. So it's just painful almost, John, to sit here and just wait as these seconds tick. A signal from Odyssey still strong, so they're still getting that direct link back. They're on powered flight now, which means the pyrotechnics.
Yes.
We're in the zone now where we should be hearing something.
They fired. Yeah, they fired the thrusters. 500 meters in altitude. How close is that? Very close.
1,500 feet.
Let's listen to mission control.
The accordion nominal. Altitude error 5.9 meters.
We found a nice flat place. We're coming in ready for sky crane. Down to 10 meters per second, 40 meters altitude. Sky crane has started. Descending at about 0.75 meters per second as expected. Expecting bridle cut shortly.
Signal to Odyssey remains strong.
Tango Delta nominal.
Yep. UDLCOM configured.
Rim stable.
UHF telemetry.
Rim stable.
UHF is good. Touchdown confirmed. We're safe on Mars.
That's it.
Oh, wow.
That is it. Curiosity is on the surface of Mars. How you feeling, Joy? A lot of joy?
Very joyful.
What a night, and it has only just begun, John. You can see the team in mission control there. What a spectacular series of events. And in essence, we were able to watch it sort of live, all unfolding before our eyes, even not seeing the real pictures. What drama unfolding here at the Jet Propulsion Laboratory here in Pasadena. Hugs and tears all around there.
Signal to Odyssey remains strong.
Good signal still, so
We're
I get
continuing
those
to receive
pictures.
telemetry from Curiosity.
We're getting data from the surface of Mars.
Data from the surface of Mars coming in.
Cam sequence is kicked
Wow.
off, waiting for images.
See if we get any images.
Waiting for the first images. Waiting for images now. We might get images pretty quickly here, John.
These will be the first black and white images, which will be pretty grainy and not very clear, right?
That's correct. The HAZ cam, as they call it, that's taking these first images, has dust covers over it because of the dust that they're flinging up as the vehicle came down, right, Joy?
Right.
So these first couple of images, if in fact we do see them, are going to be a little blurry, right?
Maybe. They could
Maybe
be clear.
not.
Yeah.
Right?
They could be
but they
clear.
could be clear.
Yeah.
But then later in the morning, they'll take the dust covers will be removed.
Right, they'll take another set
And
of
they'll take
pictures.
another set of pictures, and they'll even be crisper and sharper images from the surface of Mars. And again, if we get these two pictures, these first two, the first one, the mission manager John Grotzinger told me would be the wheel, one of the wheels, the rear wheel.
Yeah.
And is that an image we're looking at?
Oh wow!
There it is. That is an image.
That is. Wow.
There's your first image from the surface of Mars from the Curiosity rover. I can't see it, but it's there.
And you know, John, one of the things that really has to be said.
You're seeing it's a fisheye lens, so you could be seeing the
What's
horizon.
that, John?
I was just going to say, when we get these images back, I didn't mean to cut off Joy because she was describing what we were seeing just then, but just how difficult this entire landing really was. They'd never tested this before. So,
you can see part of the wheel.
No, that's absolutely right. They had never done, they tested every single aspect of this landing in the best ways they could, using helicopters, using wind tunnel testing, you know, they did the sky crane testing. Everything was tested, but they couldn't test everything together, and they certainly couldn't test everything, you know, on Mars. So this, in essence, this was the test. It is not only the test, this is a testament to this incredible, incredible team out here and all around the world. There's 400 people on this team, you know, scientists and engineers from all over the world. You know, a testament to the ability of these people, and that is through the fisheye lens, right, Joy? So that, go ahead.
And it's a 64 by 64 pixel image, a small thumbnail, and we'll wait later. We'll get bigger versions of those.
But that is the rear wheel on the surface.
Yeah, we can tell that we're seeing the wheel, and we're seeing the horizon with the fisheye lens. It makes a bowed mark. It's the same cameras that we had on Spirit and Opportunity, but mounted up much higher off the ground.
And the second image that we hope to see would be one from the same HazCam, right, but looking out the front.
Well, actually, you might see from the left, so the right and left, and then we'd probably see the front after that, but we're not sure. We were not sure how many images we would get tonight.
Well, any images is great news.
It is.
John, back to you there.
Sure, John. And what we'd like to do now is just listen in to the excitement and this moment at Mission Control there at the Jet Propulsion Laboratories in Pasadena in California.
So there could be more.
There could be more. If we wait, we might get, oh yes!
Ah!
This is the high res, this is the 256 by 256 image. This is a higher resolution. You're seeing dust particles on the window. You can see the horizon there in the background. And there is the wheel of the rover safely on the surface of Mars. I can't believe it. This is unbelievable. We might get another one of these, and if we're lucky, before Odyssey goes away, we'll get 2 more of these same images going the other side of the vehicle, and also probably dusty. This is amazing.
So that is one of Curiosity's rover wheels
exactly.
on the surface of Mars.
Yes. Whoa, wow. Now we have another image coming down. This is a view looking the other direction. It's still
And
being
we have been
processed.
watching the scene live at the Jet Propulsion Laboratory there in California as the engineers and the scientists and Mission Control celebrate what has, at least for the time being, been this very successful start to this mission. No one knew they could do it. It was all pretty much untested, but it does appear to have been successful. Curiosity is on Mars, sending back photos. And John, you're there with Joy Crisp, who is the Deputy Project Scientist. She must be, amongst all of those other people there, incredibly happy right now.
Thank you.
Yeah, Joy, you know, the question was, you must be incredibly happy. I'm sure you would be much happier if you were in there celebrating with them, but we thank you for being out here with us. So what are you feeling right now? I mean, a lot of years have gone into this for you.
A lot of years. My whole mind is transitioning now to, okay, what's coming up in the weeks, months, and years here. It's going to be very challenging, but really exciting to see what Mars tells us about its past.
And working on Mars' schedule too,
Yeah,
right? You got to
yeah.
turn your life upside, work at night and sleep during the day.
You have to
and-
become a Martian.
You have to become a Martian. And for the next couple of years, everybody on this science team are going to be Martians, that's for sure. But I'm sure it hasn't quite sunk in yet.
It hasn't.
Were you confident? Did you think?
Oh, no. I don't know. I had mixed feelings. I kind of can't believe it. I've worked on Pathfinder, Spirit, and Opportunity, and every time you get those first pictures, it's always amazing to me that it made it. It was intact, and it all works. Yeah.
Well, you know, the NASA's had a good track record.
Yeah.
Hey, John, I'm going
very
to
well
interrupt
getting
you
these
just for a
probes onto
moment.
the surface. Go ahead.
John,
Go ahead, John.
I want to go back to. Oh, we don't have David Brody. I thought we had David Brody, but we don't have David Brody. But actually, maybe we could ask Joy this question, John, because there's so much for NASA riding on this, because there's no real backup, there's no real other space program in the works. This was it. And there's a lot of hope in NASA that if this is successful, it may spur a lot more interest for a very cash-strapped U.S. government to continue on with Mars exploration.
Hey, you know, we've talked a lot that so much was riding on this mission. Mars exploration, there aren't any big missions down the pipe right now, that this could spur, you know, more Mars exploration, the success of this. And the failure, if it had happened, might have had the opposite effect.
That's true, and you know, for everybody that's worked on it, it's just a whole lot of effort that we put into it. We wanted it to work. So for us personally, we had a lot at stake.
But you knew the pressure. You knew the pressure was on.
The pressure was on, but it you know, personally, it kind of comes down to all the effort that you put into it, and that you see all of your friends putting into it. It also has such wonderful payoff for kids that get excited about science and technology. So that's a really big, important part of this, to inspire kids.
I think that's one of the big things, John, when you see these successful missions like this, you know, it helps breed that interest that Joy pointed out in science, in engineering, in mathematics, and all of those things. All of those things that every one of those people in that control room have. And that, you know, the next generation will certainly need to have. And that's an important thing to keep, you know, the flow of brain power going. John?
Yeah, and just looking at those images there at JPL as Mission Control, as NASA celebrates what has been a successful touchdown by the rover Curiosity, the biggest space probe ever to be sent to the Martian surface, capable of traveling the surface, climbing mountains, collecting samples. It has laboratories on board. In a couple of weeks, it'll start taking those samples, essentially looking for the building blocks of life. It is trying to find carbon on the planet Mars, and we are continuing to watch the situation there. A lot more on this story, but for now, I'd like to take a short break. And welcome back to World Report, an historic moment where NASA's Curiosity lands on the surface of Mars to begin exploration for the basic building blocks of life. It is a very excited mission control, successfully landing on Mars, using techniques which have never really been tested before. Now let's go back to John Zarella, who has been there for this moment. He was there in the build-up to it. He's there right now. And John, of course, now comes, I guess, the hard part's over. Now comes kind of the difficult work, if you like.
Yeah, and you know, we haven't really talked much about the fact of where they landed. And Adam Stelzner, who was the entry, descent, and landing chief, in an interview we did with him, in an interview we did with him, he said, you know what? We're landing between a rock and a hard place. And of course, what he meant was they're landing in this in this crater. On one side, you have a crater wall, and in the middle, you have this giant mountain called Mount Sharp. And they had to put the Curiosity down right in between there. And they went to this spot because this is the spot where they believed, and Joy, I'll bring you in, where you believe their water may have flowed on the surface there many, many eons ago. And also, because of that crater wall, you can really look back in time at all of the different layers of history, right?
In the mountain, actually.
In the mountain.
So in the wall, there's some material that was shed off the side of the wall that water brought down. So that's interesting. And then on the mountain, you have layer upon layer for 3.5 miles, a stack of different ages of rocks with clay minerals at the bottom and then sulfate minerals higher up.
And as you look at that, you're going to be able to see a period in Mars history when it was
wetter,
like us,
yes.
More Earth-like,
That's
correct?
What we think.
That's
so
what you think.
We want to find out by interrogating those rocks and seeing if there was a change in the environmental conditions as you move up and find sulfate minerals.
So, John, what you might end up have is, an ability to find out what went wrong on Mars. Why did Mars turn out the way it did, and why are we the way we are? And that's one of the things that they may be able to at least start to get answers on. And now, we're getting a lot of the people who had gathered here to watch. They're all coming out. They're excited. We may try to grab somebody if we find anybody else coming over here, like the NASA administrator, Charlie Bolden, who is here, as well as a science advisor for the White House, who is here. John?
Yeah, it is an exciting day when you think that you have been successful in getting the Curiosity on Mars, because, let's face it, you're about to add to the sum total knowledge of mankind. And this has been such an incredibly difficult mission. So let's talk to Dave Brody at space.com about that. He joins us once again from New Jersey. And Dave, sending probes to Mars is notoriously difficult. 1/3 of the missions have succeeded, the rest have failed. The US has had a lot of success, but not like this before.
No, not at all. And what's great is that we keep pushing the envelope, not to honk the horn of the United States. Humanity is pushing the envelope. We are doing, as NASA speaks of this mission, we're daring mighty things. And, that's what we should do, because you have to remember who we are. 800,000, 1 million years ago, there were probably some folks in North Africa who said, no, don't go over that next mountain. Don't cross that river. We don't really need to go there. We're just fine right here. Don't really need to know very much more. Those folks are not our ancestors. We are the descendants of the ones who left. We're the ones who were eternally curious, who went and tried to cross the river and invented a technology to get across to the other side that was safer than swimming. And Curiosity, the rover, is the direct descendant, if you will, of that technology. It seems to be what we do, and I'm glad we were brave enough to do it tonight and do it successfully.
Sorry, Dave, what's the bottom line here? What's the best outcome here for what Curiosity could discover?
It's always dangerous, particularly when you're talking about another planet, to speculate on what you could find, because Mars has always surprised us consistently, from the ancient astronomers looking at it right on down to the present day. It always throws us a curveball. We keep asking Mars, "Do you have life?" And Mars keeps saying, "Can you repeat the question?" So what we'll find out with Curiosity is, does Mars have complex organic molecules? But there's another story that's part of the bigger picture that's really seeping into the consciousness of our space.com viewers. We get a lot of email about this, and that's the methane story. There is methane, we think, in the Mars atmosphere. Now, methane can come from things like volcanic activity, but it seems like Mars has long ago shut down those things. And we really want to know, what's the story of this methane? Because methane can also come from life. One of the principal sources of methane in Earth's atmosphere is, how to put this delicately, bovine flatulence.
Right. Hey, now let's talk about what Curiosity likes to be doing. It'll be collecting samples, and it will be analyzing those samples with onboard labs. I mean, ideally, it would be great if you could bring that stuff back to Earth, but we're still a long way from that, right?
We are closer than we were 14 minutes ago. as a result of being able to do this particular type of landing. You know, once again, our space.com viewers and audience are like, why would NASA choose to do it this way? The answer is that's the only way you can land a rover this heavy on Mars. You know, this thing is a beast, as you mentioned. It's 900 kilograms or so. So now we have a way to land heavier vehicles, which could include the ability to go out, collect a sample, and launch it back on a trajectory that could get to Earth. We'd really like to do that because then you have a little piece of Mars that's fresh. We actually do have pieces of Mars on Earth already. There are Martian meteorites that were blasted off of that planet in its ancient history that land in Antarctica. They sit in the Antarctic ice cap for a while. They melt out. Scientists go and collect them. So we have little tantalizing samples of what Mars used to be like a long time ago, but we could actually get a sample of what Mars is like right now. And that's truly fascinating.
And what we're actually expecting from Curiosity in the next couple of hours, the next couple of weeks, what I found interesting was a video of the last minute or so of the landing. What can be learned from that?
Indeed. Well, that's really important. Not only will it be exciting, but yes, once the bottom of the protective part of the vehicle comes off, there is a camera called a descent imager that looks at the surface. That's really important because, first of all, it tells you exactly where you are on the ground. They take those pictures, they take that video sequence, and relate it to the imagery from Mars Reconnaissance Orbiter, Mars Global Surveyor, Mars Odyssey, some of the satellites that are in orbit, the spy satellites around Mars that John and Joy talked about a few minutes ago. So that's a way that the rover drivers can know exactly where they are, in addition to looking out with the cameras and triangulating, figuring out, you know, just how far is it to Mount Sharp or Aeolus Mons, as it's known technically, to start that long climb up. It's good geology work. But Joy Crisp is still standing by with John, but I have a question for her. We spoke about peanuts tonight. I wonder if Joy Crisp is wearing her hematite necklace.
Hey, Dave, we'll pass that on. We're having a little bit of technical problems getting to Joy. It's amazing. NASA can put a rover on Mars, but we're having trouble with our connection to California right now. But Dave, stay with us. We appreciate your insights so far on this story, and there's more on the best news that NASA could have asked for with the Martian rover Curiosity. It is on the planet right now. And of course, over at JPL, there have been these celebrations of this historic moment with the Curiosity touching down using untested technology, untested techniques. So much could have gone wrong. There was zero room for error. It appears there was no error. The photographs have been sent back already, and there are a lot of happy people there right now. I'm going to take a short break here on CNN, and we will have more on this story when we come back. An historic night at the Jet Propulsion Laboratory in Pasadena, California. History is made by the U.S. space program. Just minutes ago, word that the robotic rover Curiosity successfully landed on Mars. A successful mission, 10 years in the planning, and we are getting pictures back from the red planet. The rover will be searching Mars for signs of past life. Our John Zarella has been at JPL from the moment this mission began, when we started getting these images in. It has been an exciting moment there, John. Just recap for us, John, exactly everything that has happened over the last 30 minutes or so.
Well, over the last 30 minutes or so, the Curiosity rover entered the Martian atmosphere going at about 13,000 miles an hour, maneuvering its way through the atmosphere. And fortunately for NASA, an orbiter called Odyssey was in the perfect position in order to get the signal back. So everything that was transpiring in the spacecraft as it was descending through the atmosphere, the maximum heating on its heat shield, the shedding of the heat shield, the parachute then deploying, slowing Curiosity down to 200 miles an hour, and then finally the sky crane lowering Curiosity to the surface. All of it was being sent back to NASA. Granted, there was a 14-minute delay because that's the time it takes for the signal to reach Earth, but it was about as real time as you can get. At that point, the cheers went up in Mission Control. The entire team absolutely ecstatic because, again, John, as we've been pointing out, they had never before attempted this kind of a landing with this large of a spacecraft on the surface of Mars. John?
Absolutely, John. It's been a fantastic night, really. It's been history in the making. It was so good to see it live here on CNN. We'll have a lot more on this story as the day goes on. We'll be talking to you throughout the coming hours, and we have a lot more on this story on our website, CNN.com. We'll be getting more pictures as they come in from Mars. That's all at CNN.com. But for now, that is it for this edition of World Report. I'll be back with another hour. We'll also have our special Olympic coverage live from Olympic Park. I'm John Vors. Stay with us. I'll be back after the break.
Are we going to get a full image?
This is a Fox News alert from New York. I'm Marianne Rafferty. Some tense moments at this very hour. The space agency just moments away from finding out if the space rover Curiosity has made a successful landing on Mars. The rover should already have landed if everything went well, but NASA isn't expected to find out until about 1:30 a.m. at the earliest. To help guide us through this exciting landing on the red planet is former NASA astronaut Tom Jones, who's joining us from our Washington, D.C. bureau. Now, Tom, this must be a very special night for a space enthusiast like you and for everyone else out there, that's watching this.
Well, Mars has been in our imagination for over a century in terms of science fiction, and for the last decade, we've had the Mars rovers, Spirit and Opportunity on Mars. This Mars rover Curiosity is 10 times bigger than those previous rovers, and we're going to learn an amazing amount of information about the suitability of Mars for past and even present life there.
And this touchdown attempt is considered especially intense because NASA is testing out a brand new landing technique. What can you tell us about that?
Well, it's a real nail-biter, Marianne. There's a sky crane system that even now is lowering the Curiosity rover to the surface. Of course, it's already there on the planet. We're waiting 14 minutes of radio delay to get the signals back from Mars to tell us whether the sky crane system is putting this 1-ton rover gently down on the surface. And we're hearing from the spacecraft telemetry signals that indicate whether each step in the automated sequence is occurring properly. And when we get the final step in that sequence that the rover is actually sitting on Mars, then we'll know that we're go for a 5-year-plus mission.
Wow, and we could hear within just minutes whether or not this mission was actually a success, but it would only be a success if the orbiter that's transmitting the information is in the right place. It seems like there is so much that they have to get exactly right. What happens if it isn't in the right place?
Yeah, we want instant feedback and the gratification of knowing that the rover is safely down.
Tom, I apologize. I'm going to go ahead and toss to NASA TV live, broadcasting from the Jet Propulsion Laboratory in Pasadena, California.
We are 9 kilometers and 8 MLEs active.
Valid range.
Net filter converged with a velocity correction of 0.7 meters a second. We've acquired the ground with the radar. An altitude of 8 kilometers.
Each has separated. We have lost X-band tones due to Earth occultation as expected. We're UHF all the way in.
The MLE engines in preparation for powered flight. We're down to 90 meters per second at an altitude of 6.5 kilometers and descending.
Flight EDL, we've got some tweeter warnings. It is in battle short mode, so I should power through them.
Direct to Earth communications at this time. We may have lost it already. We're down to 86 meters per second at an altitude of 4 kilometers and descending. We've lost tones from Earth at this time. This is expected. We're continuing on Odyssey telemetry.
Ground solution equals minus 10.8 meters, vertical velocity of minus 82.8 meters per second.
Start enabled, standing by for backshell separation.
Signal to Odyssey is still strong.
We are in powered flight. We're at an altitude of 1 kilometer and descending, about 70 meters per second.
Signal to Odyssey remains strong.
50 meters per second. 500 meters in altitude.
Standing by for sky crane. Constant velocity accordion nominal. Altitude error 5.9 meters.
We found a nice flat place. We're coming in ready for sky crane. Down to 10 meters per second. 40 meters altitude. Sky crane has started. Descending at about 0.75 meters per second as expected. Expecting bridle cut shortly.
Single velocity remains strong.
Tango Delta nominal.
Yeah. UVLCOM configured.
Rim stable.
UHF telemetry.
Rim stable.
UHF is good.
Touchdown confirmed. We're safe on Mars. Time to see where our curiosity will take us.
All right, we now know that the Curiosity landing was a success. Lots of celebrating going on right now at the Jet Propulsion Laboratory in Pasadena, California. For now, let's go back to former astronaut Tom Jones. Tom, what's your feeling about this right now? We see all the celebrating, but what exactly does this mean now that the landing was a success?
Well, this just opens the next chapter in Mars exploration. Congratulations to NASA on this amazing technical feat of putting Curiosity down. And so there's about a 5-year mission ahead of us, Marianne, to set the Curiosity rover climbing a 3-mile mountain in the Gale crater, looking for evidence of hospitable climates on Mars for past life, and looking for the chemical tracers that life may have once existed there.
Tom, you just mentioned the Gale crater. Why did NASA pick the Gale crater in particular as the landing spot?
Because orbital photography from the Mars Reconnaissance Orbiter and other spacecraft has indicated that Gale was once a depression filled with water, a lake on Mars. And the chemical conditions, the climate conditions billions of years ago may have been correct for the origin of life to have occurred there. So they're investigating a likely spot where life may have been harbored on Mars.
This is just amazing to watch. We really haven't seen the pictures yet. We're expected to get the first pictures from Mars in just a few minutes, but what can you tell us about what we might see?
Well, at the bottom of the Curiosity rover, on the belly, just above the wheels, is a camera, a set of cameras that are taking images of the dirt directly below the touchdown point. So as the rover sits on the ground the size of a Mini Cooper, it'll be looking at the ground directly beneath it. A small postage stamp sized image just confirming that they're on the surface, and we'll get our first very gray, very blurry images in the next few minutes, up to about 2 hours from now, depending on how the relay comes. And that's confirmation that the original images are coming back safely through the relay satellite.
Wow, again, we're showing all that celebrating. This was very long coming for the crews that were working on this. Now, if Curiosity does end up finding water or any other signs of life like we talked about, how significant would that be to us? And while we're speaking, Tom, by the way, we're seeing the first image actually from the landing itself. But wanted to find out if they do find water, if they do find life, what does that mean for us?
Well, finding actual life on Mars, which is not the actual job of this rover, they're going to look for the traces of hospitable climates and chemical traces that life might be there. It's really not set up to look for living organisms. But once we discover that evidence, that's going to change the entire idea of our place in the universe. Life on Earth will not be unique. It will have arisen somewhere else, and that'll, of course, tell us that there could be millions of planets in our Milky Way galaxy that could host life, as well as several places in our solar system. So it's got immense significance for finding our place in the universe, and what that tells us about our chances of finding other intelligent civilizations out there.
You know, and they had talked about the fact that this was, they called it the Super Bowl of planetary exploration, because they said, we've got to win, or, if we lose, that's going to be a really big problem, because the whole program was sort of depending on the success of this. What can you tell us about that, and why this means so much to these crews?
It really is a do-or-die moment. This project has been in development for about the last 10 years, since the last rovers put down on Mars, and even before that. And had it failed, Curiosity would have left a vast vacuum in NASA's Mars exploration plans. There would have been no funds for a follow-up, and we would have had a real retrenchment in NASA's ability to explore Mars, and perhaps even giving up our ability to lead that effort in the future. So it defers those questions of whether or not we're going to follow up on this success for at least a few years while we watch the Curiosity discoveries unfold. NASA still has to make up its mind with the administration about whether we want to continue this ambitious program or scale back. And the latest budget cuts seem to indicate that we're going to be scaling back after the Curiosity mission is over.
And, you know, we're talking about, you know, finding water or other signs of life, and other rovers have found things like they found some ice, one of Mars's poles. You know, something like that would be, as you were saying, very significant and may show that there was life previously at some point on Mars. And that maybe, does that mean that in the future, if the planet, you know, heats up, that possibly there could be life again?
Well, if life once got established on Mars, it probably was just like life on Earth, very hardy and adaptable. So it may be surviving there today beneath the surface at a warm, hot spring, for example, protected from radiation by the soil and rocks above it. So this rover has a small drill that's able to drill down through something as hard as concrete. It can find those chemical tracers of life even beneath the surface. If we find the conditions were right and the water exists in Gale Crater and the chemical tracers are there, that would indicate the need for a follow-up mission, a more sophisticated rover. And eventually this is going to be the big draw for human explorers to go there to really get to the bottom of the questions of life on Mars. You know, maybe a drill rig team that can drill hundreds of feet below the surface to look for actual living microbes, or the fossils that indicated that they were once there. So it's going to call for a sophisticated follow-up, and we don't know the answers yet, but they will be interesting answers no matter what they are, and perhaps they'll open up this new draw towards human exploration of Mars.
Yeah, that probably sounds like something from a science fiction movie to a lot of people, you know, that you could actually someday have humans exploring Mars. How far off would that be? I mean, first of all, they need to find some signs of life like we talked about, but how far off would it be humans actually being on Mars doing some exploring?
Well, we would expect that this probe would be followed up by a return sample mission, which would actually return rocks from Mars for analysis here on Earth. And while that was taking place, astronauts going beyond the space station to the vicinity of the Moon and nearby asteroids would be doing their homework to bridge this vast gulf of at least 35 million miles between Earth and Mars. I think by around 2040, at the current pace, we might be ready to send human explorers there, but that's entirely dependent on many, many small steps taking place in the next 25 or 30 years, with each successive administration and NASA trying to build up these capabilities for propulsion, for life support, and for survival and existing on the surface using the resources, the water, the ice, the atmosphere that's already there. So there are a lot of technical steps that have to happen. We can be doing that work starting right now.
And Tom, for anybody who has just tuned in and is looking at all this celebrating going on at the Jet Propulsion Lab in Pasadena, once again, this was a very expensive mission. There was a lot riding on it. Can you tell us once again how significant this is, what this means for the future of Mars exploration, not just Mars exploration, but planetary exploration?
Well, it was a big investment on NASA's part, $2.5 billion, and that's a very expensive planetary mission. Had it failed, it would have been a time for NASA to look at itself and see whether it could manage these complex missions successfully. The success means that we've got an amazing new capability for looking for past traces of life on Mars, and it shows that the U.S. is the only nation on Earth that can put down a sophisticated lander like this. No other nation has put anything successfully on the surface of Mars. So it does preserve our technical leadership, and it remains for us and for NASA to show whether or not we intend to continue and follow up with future robot scouts, and then the intention of putting people there for good. And I think this is one of the major scientific questions of the 21st century, to follow up from the discoveries of Curiosity in the future here.
And I want to talk about, once again, just what a major feat this was for the rover to actually land. I mean, everything that had to happen and had to happen exactly at the right moment, and different things could have gone wrong. Again, explain how significant it is that they were able to pull this off exactly the way they had planned.
It truly is amazing and astonishing. We're seeing these first couple of gray images from the surface showing the dirt around the Curiosity rover. So what happened was the engineers put this spacecraft in a box and launched it to Mars last November, and it slept silently, cruising to Mars for these last 8 to 9 months. And now, as the package unfolded in the last 7 minutes before touchdown, everything worked amazingly in sequence. And this sky crane concept, the first time it was ever tried, put this 1-ton rover down on the surface. So you really have to hand it to this engineering team and the scientists who developed this mission and then pulled off the landing. So I can only imagine the release of adrenaline and excitement and satisfaction that's going on in California right now.
And what the fact that this went very well and everything happened the way it should, you know, and again, we saw how excited and happy these crews were after working on this for so long. How is this going to affect our exploration of other planets that we were considering exploring? And you know, will we now be able to get the funds needed to do that?
This is a great question because, Marianne, the White House proposed a 20% budget cut for NASA's planetary exploration program in the next year's budget. And this great success, I hope, will inspire the public, cause a great amount of interest in NASA's Mars and other planetary exploration missions, and maybe they can marshal the public and congressional support to restore those cuts and follow up at a more sophisticated level with Mars exploration and with missions to the asteroids nearby and perhaps to the moon, so that human explorers can follow up these kinds of exciting robotic discoveries.
All right, Tom Jones, former astronaut, thank you so much for being with us. You have been watching special coverage of the space rover Curiosity's landing on Mars, which we now know was a success. I'm Marianne Rafferty. We'll take you back to Geraldo at Large, already in progress after the break.